Hey, what's up, guys? Welcome back to my channel and glad to see all of you guys here today. So today we are going to talk about phase change in thermodynamics while we are boiling water. So let's get it started. So we boil water every day in our kitchen, and it can be simulated as an open system boiling process. Then as we heat up the water, heat is added to the liquid. And in this process, the pressure is constant, and we call it as an isobaric process. So we call it as constant pressure because it connects to the atmosphere directly. So the pressure is always equal to atmospheric pressure. So it's a constant pressure process. And also it's an open system process because the gas can go to atmosphere without any volume limitation. So it's an open system. So while we are boiling water, as a common sense, we know it's 100 degrees C as the boiling point. And the boiling point, we also call it as saturated temperature. So we think that's 100 degrees C, and it's actually 99.62 degrees C. And we think it's 100 degrees C or 99.62 because it's always under the atmospheric pressure, which is 101 kPa. However, if you go to high elevation places, then the atmospheric pressure will be no longer 101 kPa. It's going to be smaller than 101. Then guess what? Then your boiling temperature, or called saturation temperature, is also going to be less than 100 degrees C. So that's the reason that in high altitude places, it's hard to cook because the boiling temperature won't be able to reach to 100 degrees C. And once it reaches to saturation temperature or boiling temperature, then phase change will happen. So H2O is going to be from a liquid phase to gas phase. And during this phase change process, the temperature remains the same. So it's always 100 degrees C. So during the phase change, the temperature will remain to 100 degrees C, and it will not change, and it will not go up, which means if you boiling water, as long as there are some liquid phase exists, then the whole system will remain to 100 degrees C, and the temperature will not go up. At the same time, the system's volume begins to increase dramatically because all this liquid water is becoming gas phase and going to atmosphere. So from liquid to gas, the volume changes dramatically. So actually it's about 1,000 times. Then as we just said, in this process, the temperature remains the same. Then you may be curious, where are all this heat go? Well, all this heat are taken out by the phase change, which is from the liquid phase to the gas phase. Then if you keep boiling until H2O all becomes to gas phase, then the system's temperature will begin to raise again. So this is the boiling water process, and it's an open system. The next one, let's take a look at the closed system of boiling. They're almost similar, and it just has a little bit of difference. So in this closed system, we make it to be a constant pressure. So the pressure remains to 100 kPa. Then at the start point, the temperature of the liquid water is 20 degrees C. Now we add heat in there. So at the beginning, the volume changed very little. Then once it reaches to the saturation temperature, which is also called boiling point, and is about 100 degrees C, phase change happens. So like we said, during the phase change, the temperature is constant and it does not change. But the volume will change dramatically. So once it reaches to saturation temperature, the H2O will first becomes saturated liquid. So it's going to be 100% of saturated liquid. Then if we keep adding heat, then some liquid will become in gas phase. And we still call it as saturated H2O. But the quality is going to be a mixture. So it's going to be a mixture between gas phase and liquid phase. And as we keep adding heat, all liquid is going to be in gas phase. And it's going to be finally become saturated 100% of gas phase. And all these three, we call all of them as saturated. So it could be 100% of saturated liquid, or it could be a saturated mixture, or it could be 100% of the saturated gas phase. Then after this 100% saturated gas phase, if we keep adding heat, then it's going to be called a superheated gas. Then the temperature will start go up again. So this is a closed system when heating up water. All right, then this is all we learned today. Hope you learned a lot. Thanks for watching. We'll see you next time. Bye.